Let's take a few minutes now to look at the law of sines. And this law applies not just to right triangles, but to all triangles. And it's important first to understand the notation on triangles. So I'm going to briefly summarize that. The three sides are usually labeled with lowercase letters. And here is side A, here is side B, and here is side C. The angles are labeled with uppercase letters, and each angle is opposite its corresponding side. So here is angle A because it's opposite side A. Here is angle B because it's opposite side B. And here is angle C because it's opposite side C. And what the law of sines says is that the three ratios, A over sine A, B over sine B, and C over sine C, are always equal to each other in any triangle, not just right triangles. So let's see how to use the law of sines to work with the triangle here in this example. And as you can see here in this triangle, we know two of the angles. Angle A is 35 degrees and angle C is 62 degrees. And we know just one side, side C is 7. And what we're going to do is try to figure out the lengths of side A and side B using the law of sines. To do that, let's first get the measure of angle B. And we can do that because we know that the three angles together have to total 180 degrees. So if angle A is 35 and angle C is 62, together they make 97. So that means angle B must be 83 degrees. So I'm going to jot that down. So next, let's see if we can figure out the length of side A. And you can see in the picture that we know capital C is 62 degrees and side C is 7. So we're going to use that ratio on one side of our equation. So I'll go ahead and write that. We have 7 over the sine of 62 degrees equals A, our unknown side, over the sine of 35 degrees. And then if we cross multiply, we get 7 times the sine of 35 degrees equals A times the sine of 62 degrees. And then if we divide both sides by the sine of 62 degrees, we get 7 sine 35 degrees divided by the sine of 62 degrees equals A. And then if we turn to our calculator and type that all in, and I like to wait and type all that in rather than get decimals along the way. When I type that in, I preserve accuracy that way, and then my result turns out to be, if I round, say, to 2 decimals, I get 4.55. So that's the length of side A. We can do a similar calculation to figure out the length of side B. And what I'll do again is use this ratio of C and sine of angle C, since those are both accurate values. And I'll go ahead and maybe work over here on the left-hand side. And I'll write 7 over the sine of 62 degrees again. That's C over sine C. And it has to equal side B, what we're looking for, over the sine of angle B, which is 83 degrees. And again, if we cross multiply, we get 7 sine 83 degrees equals B times the sine of 62 degrees. And then if we divide both sides by the sine of 62 and put all that in our calculator, we end up with B equal to, rounded to 2 decimals, 7.87. And I'll go ahead and box that result. One nice check on your work is when you're done, the largest angle should be opposite the largest side, and the smallest angle should be opposite the smallest side. So let's see if that happens here. First of all, angle A is the smallest angle, and its length, side A, is only 4.55, the smallest side, so that's good. And then the largest angle is angle B. It's 83 degrees. And its length of side B was 7.87, and that is the longest side. So it looks like our work seems to pass that test. And then there's one more observation I'd like to share with you, and it applies again to all triangles, not just to right triangles. I'm going to go over to the next slide. What we have in this picture here is a triangle shown in blue with its 3 vertices in red. And around that triangle is the one unique circle, and it's in green here, that goes through those 3 vertices. Every triangle, no matter how acute or obtuse or right it is, has one circle that goes through its vertices, and it's called the circumcircle. And the law of sines that we saw before, A over sine A equals B over sine B equals C over sine C, actually also equals 2 times the radius of that green circle, that circumcircle. In other words, this ratio is equal to the diameter of that circle. And it's kind of a nice relationship. And that's it.